Good afternoon. Thank you for joining us. My name is Thomas Lazzara. I'm Director of Research and Development at Meissner. Today, I'd like to present an improved method of characterizing ultrafiltration membranes, specifically in regards to our hollow fiber product line, Seprapor. So ultrafiltration is typically used in downstream processing, such as antibody purification, and continues to be an important element in many recent fields, such as mRNA and VLPs. Ultrafiltration also remains a critical purification tool in emerging cell gene therapies involving viral vectors and lipid-based vectors. The ultrafiltration membranes we'll be discussing today are specifically in the form factor of hollow fibers, which are an expansion of our Seprapor tangential flow filtration product portfolio. As most of you may be familiar with, these hollow fibers are operating in a tangential flow filtration mode, with the bioprocessing fluid flowing parallel to the membrane surface with a sweeping action that reduces membrane fouling. So hollow fibers have a superior performance to cassettes. They provide faster processing times, lead to greater process efficiencies, while maintaining higher fluxes without compromising on product recovery. Today, I'll cover 3 discussion points for these ultrafiltration membranes. First off, a section on characterization, where we discuss the improved assignment of molecular weight cutoff for ultrafiltration. The second one is performance, where we're going to talk about permeability and reduce lot-to-lot variability. And finally, an application, one of our recent applications of ultrafiltration membranes in the plasmid DNA purification in a UF-DF step. So 2 properties really are used to characterize UF membranes, which are permeability and porosity. Permeability is measured as the clean water flux in LMH per bar. Porosity is a little bit trickier. It's typically characterized by secondary methods involving molecular weight markers. Could be proteins, could be polymers, or another marker, to obtain a molecular weight cutoff value, the MWCO. So MWCO is typically obtained from the passage of molecular weight markers using a filtration test and scientific instrumentation to determine the degree of membrane crossover, as illustrated to the right. So in this characterization section, I'd like to highlight the more extensive characterization we apply to Seprapor ultrafiltration membranes in comparison to another commonly used supplier identified here as supplier A. So Seprapor uses a minimum of 3 molecular weight markers to characterize the molecular weight cutoff of an ultrafiltration membrane accurately. So shown here is a 300 kilodalton membrane. So you see 3 molecular weight markers are being used. Supplier A, on the other hand, only uses 1 molecular weight marker, shown in gray. So for each molecular weight marker tested, the degree of passage is shown on the y-axis. Molecular weight markers used are shown on the x-axis, with 1 being the smallest, lowest molecular weight, and progressively increasing molecular weight with increasing number. So the advantage of using 3 molecular weight markers becomes apparent when you compare additional porosities. So we had a 300 kilodalton. So for a different molecular weight cutoff, say a 300 kilodalton, the passage range at different molecular weight markers are lower and specifically have overall lower overlap, as shown in red on the left graph for Seprapor. Supplier A, however, has 100 kilodalton range determined using the same molecular weight marker as the 300 kilodalton membrane, and there's significant overlap of the passage range. So you there have, to some extent, product specification overlap. So there's not only overlap between, let's say, 100 and 300, there's also overlap with a 500 kilodalton membrane, because supplier A uses the same molecular weight marker for all 3 membranes. So for some test values, such as the red circle, it'd be difficult to differentiate between these porosities. Also, using a single molecular weight marker does not provide additional information on how the retention profile, which is how the passage changes at different molecular weight markers, shown by the dotted lines. So the shape of the curve itself depends on different factors, such as pore density, pore size distribution. So in general, let's say if the shape of the curve is unknown and you have product specification overlap, then the filtration performance unfortunately becomes membrane lot dependent for a customer. So taken together, the passage ranges for different molecular weight markers for Seprapor generate what we call passage bands. These passage bands are unique to each molecular weight cutoff, with a minimal overlap between them. Shown here are for 10 kilodalton, 550, 300, and 750. So SepRapport therefore provides a more in-depth membrane characterization than other membranes on the market because it has defined and unique passage bands. So SepRapport, you can say, is defined accurately, reproducibly, and without ambiguity. So I'd like to now transition to the next section of the presentation, where we'll cover some of the performance aspects. So in terms of performance, we want to highlight how this extended characterization process provides better lot-to-lot repeatability. So SepRapport ultrafiltration fibers are manufactured with the aim of having their filtration properties match their allocated passage band. So here are shown different UF membrane lots in this graph that are shown to fall within the allocated passage band for a 300 kilodalton membrane. So this would be considered as part of our lot release criteria. So we realize this is a more demanding characterization, but we're confident that it improves lot-to-lot consistency, and for our customers, translates into lower process variability. So finally, also I want to touch base on the flux. So this slide here highlights the flux of SepRapport membranes, which we believe have high flux values when comparison to other industry available products. Water permeability is shown for various molecular weight cutoffs that are offered. What I really want to highlight is we strive to offer a boundary conditions, and together with an accurate and precise molecular weight cutoff, having available typical flux boundaries means that you'll have a more predictable process performance. And finally, in the final section, we'd like to highlight a recent SepRapport ultrafiltration application where it was successfully used in the purification of plasmid DNA, specifically in UF-DF step. So in this process, as shown here in the diagram, SepRapport was used prior to chromatography and sterile filtration. So using SepRapport, we demonstrated that we can achieve process intensification in comparison to traditionally used cassettes. Ultimately, hollow fibers allow us to overcome design limitations in cassettes that prevent high filter throughput, as illustrated in this graph. This is something the end user experienced. So in cassettes, inlet pressures can spike when trying to increase the feed flow rate in comparison to hollow fibers, which have much higher throughput rates and therefore more effective filtration. So this is summarized in this table here, highlighting the difference between the cassette that was used at 1.5 square meters and the SepRapport hollow fiber filter that was used at 0.36 square meters. So we can see that using SepRapport, which much lower surface area, operated at double the flow rate of a cassette, reduced the amount of diafiltration volumes, and reduced also the processing times below 5 hours in comparison to 8 hours. So overall, we saw that using SepRapport allowed to reduce the filter surface area by over 50%, allowed greater than 25% savings in buffer consumables, and reduced the overall processing time by over 40%. So in conclusion, SepRapport hollow fibers were developed with higher industry standards. We think we have some advantages here: better flow rates, improved characterization, and which leads to accurate and precise porosities and lot-to-lot consistency. So if you haven't taken any notes, I hope you at least take away this message highlighted in blue here, that well-characterized membranes allow your processes to run at peak performance consistently. And thank you for your attention. If you have any questions, please join us at booth 1135, and we'll glad to have a conversation. Thank you.